Hello, this is Dr. Mahesh Kalyanshetti, Associate Professor, Department of Civil Engineering, Walchand Institute of Technology, Solapur. Today we will discuss on coefficients of earth pressure. The learning outcome will be at the end of this session, the students will be able to evaluate the various coefficients of earth pressure. In the previous session, we have discussed about the types of earth pressure, wherein we have three types basically. One is the earth pressure at rest, another is the active earth pressure and passive earth pressure. And we also discussed in which circumstances these particular pressures are generated. The earth pressure coefficient is nothing but it's a ratio of horizontal pressure to vertical pressure, which is developed within the soil mass at the back side of the retaining wall. So, here the coefficient of earth pressure at rest condition we will consider first, which is denoted by K0, and the rest condition, as we already discussed in the previous session, is that the rest condition is nothing but the soil pressure exerted when the retaining wall is not allowed to move laterally. So, it has got a restrainment. So, under such circumstances, whatever is a ratio of the soil pressure we get in the horizontal direction as well as in the vertical direction, that ratio we call it as earth pressure coefficient at rest condition. So, here just to derive this particular formula, one soil element is considered, wherein you can see here this soil mass is the soil element is subjected to two pressure. One is in horizontal direction, which is denoted by sigma h, and another is in vertical direction, which is denoted by sigma v. And since as we have already discussed that the soil deformation vertically under its self weight, but is prevented from deforming laterally because of an infinite extent in all lateral direction. Therefore, the lateral strain developed within the soil mass is going to be 0, as we consider that there is no lateral yielding of the soil mass. Therefore, lateral strain must be equal to 0. So, this lateral strain is written like this. So, lateral strain is nothing but it is a summation of strains in all the directions. So, in its own direction, in the horizontal direction, the strain will be stress upon modulus of velocity, and the vertical direction and in the another direction, these will be the lateral strain. Therefore, it will have a negative sign, and these particular strains will be multiplied by Poisson's ratio. So, therefore, the strain in the two lateral directions will be sigma v by E, and in a horizontal direction again it will be sigma h upon E, and these two are in a lateral direction. Therefore, it is multiplied by Poisson's ratio and it has got a negative sign, and summation of all these strains must be equal to 0. Therefore, it is been equated to 0, and after simplifying this we get the equation sigma h upon sigma v is equal to mu upon 1 minus mu. So, this sigma h by sigma v we call it as lateral earth pressure coefficient, and it is given by mu upon 1 minus mu, and later on this particular value we can write in the determination of earth pressure, that is sigma h is equal to K0 into gamma into Z. So, our focus here was to just understand the formula of earth pressure coefficient at rest. Therefore, we just discussed here the determination of value of K0, which is nothing but mu upon 1 minus mu, where mu is the Poisson's ratio of the soil. Now, there are some typical values of the earth pressure at rest given by many researchers. Of course, you can see here the different formulas we get of K0 as per the various researchers. Then a typical table also is represented here, wherein some values of K0 is represented for different type of soil in dry as well as in saturated condition. So, these values of K0 one can refer in the absence of the data. Just to understand this process, we will have a discussion on the one example. So here you can see a rigid retaining wall 6 meter high is restrained from yielding. The backfill consists of cohesionless soil having phi equal to 26 degrees and gamma is 19 kN per meter cube. Compute the total earth pressure per meter length of the wall. So here you can see the earth pressure is given by this particular area of this triangle, because pressure at the base is K0 into gamma into H, and the area of this triangle will give you the total active force, total force in rest condition, which is nothing but the area of this triangle, that is 1/2 into base into height, means 1/2 K0 into gamma into H into H. So that's why it is H square. So after substituting all the formulas, because we know K0 is actually 1 minus mu upon mu in the previous slide, but in the case of not availability of the Poisson's ratio, one can refer the formula which are shown in the previous slide. So here I have referred this equation 1 minus sin 26 sin phi. So this gives me a value of K0, and ultimately we got the total force as 192.1 kilonewton per meter length of wall. Then there are many earth pressure theories as far as the active and passive earth pressure coefficients are considered, because the several investigators have proposed many theories of earth pressure after a lot of experimental and theoretical work. Of all these theories, those given by Coulomb and Rankins stood the test of time and are usually referred to as classical earth pressure theories. And these theories are considered reliable in spite of some limitations and are considered basic to the problem. These theories have been developed originally to apply to cohesionless soil backfill. Since this situation is considered to be more frequent in practice, and since the designer will be on the safe side by neglecting cohesion, the latter researchers gave necessary notification to take into account the cohesion, surcharge, submergence and so on, because at the time of derivation of the formulas these particular parameters were not taken into considerations, but later some researchers have worked on this and they have given some modifications in these original equations where we can incorporate these parameters. The Rankins earth pressure theory, let us try to understand. So this is the theory developed in the mid of 19th century and is one of the foundational model used to estimate the lateral earth pressure on retaining structure, and it assumes a simplified soil structure interaction and especially useful for cohesionless soil with horizontal backfill. And there are certain assumptions for this Rankins analysis, as the first one is the soil is homogeneous and isotropic. So soil mass is considered homogeneous and isotropic. The backfill surface is planar and horizontal, it means backside of the retaining wall the backfill is having a planar and horizontal surface, that means no irregularity is there, and wall is smooth and vertical. So backside of the retaining wall is smooth and the retaining wall is vertical, and wall movement is sufficient to mobilize the active or passive pressure. So because of the movement of the wall, this active and passive pressures will get mobilized, and as we already know that for active case the wall moves away from the soil, and for passive case the wall moves towards the soil mass, and there is no wall friction is considered, as it is already said that the wall is smooth, it means that there is no wall friction present. So with this particular basic assumptions, Rankine has developed theory which is being shown here. Again, as you can see here, the retaining wall is present here and a typical element in the soil mass is considered, and as the retaining wall is moving away from the backfill, the yielding of the soil takes place. It means that the gamma H goes on reducing, and at one particular point the soil mass fails. So as it is being shown here, the first inner circle represents the first equilibrium position, but as the wall movement is away from the backfill, then the sigma H goes on reducing. Therefore you can see sigma V is constant, sigma H is reducing, means that I will get another circle here. Then again with the further movement of the retaining wall, again the sigma H goes on reducing, you can see another big circle, and this movement goes on continuous till the corresponding circle touches to the failure envelope. So, once it touches to the failure envelope, it represents the failure of the soil, and that Mohr circle which is touching to the failure envelope is considered for the further analysis. So, which is shown here on the right hand side, that Mohr circle is shown here which is touching to the failure envelope, and then as you can see here, this particular angle is phi here, friction angle, because it is starting from the origin here. So, this is a friction angle phi, and this angle, the inclination of the failure plane, this gives you the failure plane, and this inclination of the failure plane is always 45 plus phi by 2, and another theory is there. So, we can refer to that theory. So, 45 plus phi by 2 is the inclination of the failure plane, so that it gives you 90 plus phi here. So, with reference to this particular Mohr circle, now we can derive the equation for the Ka. In fact, active earth pressure is nothing but it is a ratio of horizontal pressure to vertical pressure. So, horizontal pressure is here, you can see this is Pa. So, OE is nothing but the Pa, it is a horizontal pressure, and OB is called vertical pressure. So, we need to find out what is OE and we need to find what is OB, and we have to take a ratio which will give me the coefficient of earth pressure. So, which is done here, a simplified process is given, and with the help of this Mohr circle, simplification is done here. So, ultimately we can see here the Pa upon sigma V, this is the ratio we are interested in. Pa is the horizontal pressure and sigma V is the vertical pressure, and after substituting these values and simplifying it, I get the equation 1 minus sin phi upon 1 plus sin phi. And this particular Pa, again we can represent as Pa equal to 1 minus sin phi upon 1 plus sin phi into sigma V, and this bracket indicates the earth pressure coefficient for active case, which is indicated as Ka. Therefore, Ka, it is a earth pressure coefficient for active case, is given by 1 minus sin phi upon 1 plus sin phi, which also can be written as tan square 45 minus phi by 2 with the help of the trigonometrical knowledge. In the same way, the passive earth pressure also can be derived here. So, again with the help of the same logic, in case of passive earth pressure, what happens, the wall is moving towards the backfill, therefore, sigma h goes on increasing and then it reaches to failure. Therefore, the circle initially, the smaller circle is equilibrium, then sigma v goes on increasing, therefore, you can see here the bigger circles we are likely to get, and one circle will touch to the failure envelope, and then that Mohr circle will consider for the derivation. So, here also we take a ratio of horizontal stress to vertical stress. So, horizontal stress is again OB here and vertical stress is OE. So, this particular things are again represented here, and accordingly the simplification is made as it has been made in the active case, and we ultimately get one value 1 plus sin phi minus divided by 1 minus sin phi, and this particular value we call it as earth pressure coefficient for passive case. It is called as Kp, 1 plus sin phi upon 1 plus sin phi, and using trigonometrical knowledge we can write it as tan square 45 plus phi by 2 also. So, these are the references which are used for this presentation. Thank you.